Okay, this is a demonstration of how to use robot rules and control, etc. So we start from this robot sample example.part. That's from this set of parts off the Accelerator Academy. So it's a set of parts in this parts underscore manufacturing underscore robomac or robo machine. Okay, so we're using this part robot underscore sample dot underscore example dot prt. So it already has a machine path already generated, and we can actually play that here. So we can see the tool as it's kind of zigzagging across the surface there. Okay, now what we want to do here though is to simulate how this would be machined using a particular robot. So first thing we have to do is insert the robot. So we're here in the Operation Navigator in the Machine Tool view, and in the setup you can see here generic underscore machine, so we double click that. We retrieve the machine from library, so we click on this icon. It's a robot that we want to retrieve, so we double click on that. And it's the first one, so this 235, 255, so it's an ABB one, so we click on that. And then here for this particular positioning, we'll use the part mount junction, and we'll just leave it at the default here, so we'll just click OK. And then that will add the robot. So you'll notice that it's a 6-axis robot, similar to the robots that are in the K2261 lab at Seneca. And it also has this positioner, and it's this positioner that we're going to find useful later on. Okay, so the first thing is, well, that position that we selected as the default is not really very good. So let's click OK here and then try to position this in a better spot. So it turns out this positioner, when we change the position, it turns out this plate is the thing that moves. So we're going to constrain our part to that plate. So we click over here onto the Assemblies tab, and then we're going to add Assembly Constraints. So we're going to mount, replace this face onto this positioner plate. Okay, so now those are in the same plane here. And then we're going to make two distance constraints. The first one is from the center line. So we click in here on this cylindrical face and then choose the center line. The center line, yes. And we're going to constrain the distance from that center line to this front face. And we're going to make that a smaller distance. Let's make it a little smaller than that even. Yeah, say 750 millimeters, that looks right. And then the other distance we're going to control is again from this center line. So we can here, we choose the center line. And then we choose this bottom face. And we're going to make this distance smaller. Let's see what that looks like. So we're going to try and make it so this is centered. Let's just make it just below the surface. Okay, so this plate here is not on the cutting zone. This is here is the cutting zone. So that works out to a distance of 0. Okay. All right, so that's what it looks like. So we click OK to that. Now, if we move up into the assembly navigator, you'll see constraints here, and we can see them visible. Let's just turn those off. So uncheck display constraints in the graphics window. Okay. So I'm a little unhappy with that, but let's go with it. Okay, actually, let's actually display those again. Let's click on this 750 millimeter one and edit that one. So we get a slightly smaller here. Yeah, 500. Maybe 550. 550, yeah. Okay, let's make that. And then turn those off. Okay, let's go back to the Operation Navigator. Okay, now, unfortunately, the way this part comes to us from the Accelerator Academy, this tool here is not in the pocket. So the pocket is this face here on the end of the robot. So what we're going to do is actually add, so we're going to insert here a tool. And we'll choose a ball mill. So of the subtypes here, we won't retrieve from the library. We'll make our own here. So ball mill. And the location is the pocket. And then we're going to make a size 20 millimeters. And we click OK. So then we can kind of zoom in here and we can see this tool. It's kind of just arbitrarily placed it. And let's make the diameter 20 millimeters. And kind of hit return there. Okay, so you can see that the tool, the diameter changed accordingly. Okay, so I'm happy with that. And I will click OK. Okay, so now in the pocket, we have this ball mill that we're going to use to shape the surface that you see here. So we need to move this operation to use this tool. So we're just going to click and drag this over top of the tool and here. And so you'll notice now the icon for this has changed to the red circle with a slash through it. That means we need to regenerate this tool path. Okay, this tool here, we don't really need anymore, so we can just get rid of it. Okay, so now we have it set up. So let's double click on the variable contour operation. And you'll notice here that the geometry is none. So what we're going to do to kind of fix this, because at various times when we're doing our simulation, the NX wants to know what part we're working with. So let's specify the part. So obviously the part is this part here. So we click OK. So that's our part. Right, sorry, okay. And then the cut area, we're going to pick that surface. So click OK. The other thing we're going to do is for robot machining, we're going to choose motion type line. Okay, and then finally, we're going to regenerate that tool path. So we go ahead and do that. click OK. All right, so we haven't done, added our, I'll go back to the Home tab here. We haven't used our robot control, our robot rules yet. So let's first of all click here. And the first thing we notice is that the tool is unfortunately not in the right orientation. So we're going to have to fix that before we go too much further. So the way we can do that really quickly is not to go back into the Machine Tool Builder. There is a Machine Tool Navigator here. And if we expand everything, you'll remember these 6 axes and the pocket. So when you created the kinematic model for the KR3 robot, you went through a similar process in creating all of these entities. Now, the other thing that this robot also has, of course, is also the positioner. We will go here, click on the part. Let's edit that and select the part again as a setup element. And to fix this pocket problem, we're going to go click on the pocket and do a very quick edit. We're going to choose the CSIS here. And I believe the correct thing for us to do is to rotate this down. Let's just check. So we'll rotate this down 90 degrees and click OK. And then we'll go back to our operation in the Operation Navigator and click on the operation, and you can see this time now the tool is in the correct orientation. Okay, now that we've done that, I believe we're going to let's go ahead and regenerate the toolpath. We can do that quickly here. So we'll generate the toolpath. Okay, so that's generated. Now, to see the robot executing this toolpath, we go into the Simulate Machine. So that's this additional simulation. Okay, so we've got the control panel here, and then the machine axis positions. If you don't see that, you can turn it on. So if I turn this off for a second and then turn this back on, that shows me basically the current status of the machine, the current pose of the machine, if you like. Now, does this actually have the positioner in it as well? It does. Okay, so let's move this down. So it's got the 6 axes of the robot and then the angle position of the positioner. So let's go ahead and simulate this. Let's maybe move out a bit and then hit play. Okay, and maybe this is pretty fast. Okay, so this is all looking good. We haven't used our robot rules, and it's already looking pretty good. Okay, so that's zigzagging away there. Now, let's maybe zoom around here and take a look at this. And you can sort of see by the end of this, like right there, the robot has actually collided with the workpiece. Actually, you can see it there. It's collided with the workpiece. So that's no good. We're going to have to fix that. So the way we would do that here is that we would command a positioner angle and set up some poses. So let's go ahead and do that. So let's click Finish here. And then move over to our robot control. Okay, so the first thing we want to do is, remember, we need a configuration. So this is the overall configuration of the A1, 3, and 5. So A1 is the overhead angle, as we talked about. So here, in order to punch that into our rules, we come down here to the rules section, go over to configuration, and hit the lightning bolt icon to use the current configuration. So that's one of the things that we need. The other thing is some poses. So let's create a new pose. We'll call this pose 1. And let's create our pose. So again, here, now you can see the tool. So we're going to move it over here to like the beginning of the tool path. And then we're going to need to rotate this. Here, here. Okay. Oh, okay, yeah, let's create a pose just to start here. Okay, actually rotate this a bit more, like so. And down. Okay, now, so to lock this in as pose 1, we would click the lightning bolt icon. Now, the other thing I mentioned is that, so that's one pose. We can use it by clicking and dragging it to the before the operation start. Now, before I create the other pose, I first want to attack this positioner issue. So if I come over here and click on this positioner icon, so we're going to here use a constant joint value. And if I sort of play with this, so if I say plus 30, positioner value, okay, if I click on it, so this is plus 30. I don't like that. I want to tilt it towards the robot. Let's tilt it at a constant minus 30 degrees then, like so, okay? Okay, so again, I'm going to use negative 30. And I'm going to use the axis. Okay, I'm going to use that minus 30 value. Okay, so I've locked this in. For pose 1, am I still happy with this? Maybe I can move this slightly closer now. And move it down. And like so. Okay, so let's use that now. So we'll overwrite the pose 1. Let's create a second pose as we did before, pose 2. And let's move this pose over to the end of the tool path. Rotate that the other way. And then bring it right out to the end of the tool path. So here you can see, because we've positioned the workpiece sort of tilting towards the robot, that we've alleviated this problem. And now the robot won't collide with the workpiece, right? Because we've tilted the workpiece towards the robot. Okay, let's use those current values for pose 2, and then we'll click and drag pose 2 into the after operation. Okay, the last thing we have to do is define the tool orientation. And here we're going to select the tangent method and make sure that the tool is 90 degrees to the path. Okay, let's apply that. And then click OK. Let's go to the Edit Rules and check. So we've got our robot configuration. We've defined that positioner joint value at -30. We've got 2 poses defined. We're using the 2 poses. Oh, let's take out this one, use at the start. So we'll just edit that. Okay, so we've got 2. We're using pose at the start is pose 1. And then use at the end is pose 2. Perfect. And then we've got our robot tool orientation. Okay, so those are similar to examples we did in class, except that now we're using this positioner rule to avoid the collision between robot and part. Okay, so let's generate the tool path. And now let's apply our rules and do a validation run. Okay, and it all looks green. Okay, cool. So now let's go back and simulate our machine. Move this down here. And we'll click play. So you'll notice now the tool piece is tilted in front. And now the machining operation proceeds without the robot hitting the workpiece. Okay, so just look at this at the end here, just make sure that it doesn't contact. Okay, looks like it comes close, but looks like it's clear. If it had hit, we could have tried an even larger position and angle. Okay, so that's basically how to employ robot rules and simulate their effect. Okay, thanks.